Hello friends, welcome back in today's session. I am Professor Fayaz Khawadi from Department of Mechanical Engineering with continuation with unit number 2, helical gear from theory of machine subject. Today we are going to discuss the terminology in helical gear. Before starting the actual definition, discussing the actual definition, first of all, we have to understand the figure which you can see on the screen. Here, the top view of the helical gear is shown here. Before understanding the terminology, you have to clearly understand what is this figure. This is the top view of helical gear. Top view of helical gear, in which you can see the helical teeth are cut here. Helical teeth are cut, number of teeth 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 teeth you can see on the top view of the helical gear, which is making angle with the axis of rotation. This is the axis of rotation. This is axis of rotation. Okay, these teeth are at an angle with the axis of rotation. DA is parallel to the axis of rotation and the teeth are inclined with the axis of rotation. DC is the inclination and DC, these teeth are making angle alpha, which is a helix angle with the axis of rotation. Okay, now there are two planes. One plane is transverse plane, which is shown here, TT. This plane is perpendicular to the axis of rotation. The plane, transverse plane TT, is perpendicular to the axis of rotation, and when that gear is cut along section TT, you can see this view here, section TT. Okay, the second plane is normal plane, NN, normal plane NN, and this plane is perpendicular to the teeth. Plane perpendicular to the teeth is normal plane, and when the gear is cut along the normal plane, you can see this section like here, section NN. When the gear cut along normal plane, normal to the teeth, NN is section NN. Okay, so there are two planes. One is transverse plane. Transverse plane you can say as plane of rotation also. Plane of rotation. The plane of rotation is perpendicular to the axis of rotation, and normal plane perpendicular to the teeth. Perpendicular to the teeth. Okay, so when teeth are making angle alpha with the axis of rotation, these teeth are making angle alpha with the axis of rotation. So the line perpendicular to these two line is again making angle alpha. So the plane TT or line TT is perpendicular to DA, and D is axis of rotation. Okay, and line DC is perpendicular to the normal plane, and N. So when these two lines is making angle alpha, so these two plane will also make angle alpha with each other, alpha. Okay, clear? When these two line DA and DC is making angle alpha, perpendicular to these two line will also make angle alpha. Okay, so transverse plane and normal plane will again make angle alpha with each other. So these two planes which are considered in helical gear, which is not considered in case of spur gear. Why? Because in case of spur gear, the teeth which are cut are parallel to the axis of rotation only. Okay, so there is no normal plane. But in case of helical gear, one new plane, normal plane, and N is also introduced here. Okay, when there are two planes, so module will be there again two, and pitch will be again of two type. Okay, so this, I think this figure is clear to you. Now come to our terminology definitions in helical gear. Helix angle alpha, as we discussed in previous session also, it is an angle made by teeth with the axis of rotation of gear. Okay, it is an angle made by helix or teeth with the axis of rotation of the gear. Now, transverse circular pitch along transverse plane, that is denoted by P suffix T, pitch along transverse plane, that is called as transverse circular pitch, and transverse module along transverse plane, module along transverse plane. So what is transverse circular pitch? PT, it is the distance between the corresponding points on adjacent teeth measured along the pitch circle. That is important. Measured along a pitch circle. When it is measured along pitch circle, it is not a straight line, it is a arc of a circle. It is a circular distance measured along circular pitch. Okay, in transverse plane, it is the distance between the corresponding points on adjacent teeth measured along the pitch circle in transverse plane. Transverse plane. This is a transverse plane. This is transverse plane. TT, plane of rotation, and that TT is perpendicular to axis of rotation. So you can see the sectional view along transverse plane. Okay. So it is the corresponding point on the adjacent teeth. It is corresponding point on the adjacent teeth measured along transverse plane. Okay, so point this center point and adjacent point of corresponding point of adjacent teeth this. So this distance along the pitch circle diameter, this is PT, P suffix T, measured along transverse plane. Okay, corresponding point, or you can see here corresponding point A and P measured along transverse plane. Okay, PT, P suffix T, pitch along transverse plane. Clear? PT, transverse circular pitch in transverse plane. So what is pitch? Pitch is a pi into module. That definition, that formula we have already studied in spur gear. Circular pitch is equal to pi into module. Okay, so pi into module. So pitch along transverse plane is equal to pi into module along transverse plane. Module along transverse plane. So what is the transverse module MT? The module corresponding to the transverse plane is called as transverse plane. PT is equal to pi into mt. And you know what is the formula for module? Formula for module is equal to d by t, ratio of d by t, small d by t for pinion and capital D by capital T for gear. Okay. Now next, normal circular pitch, P suffix n, circular pitch along normal plane. That's why it is given P suffix n, circular pitch along normal plane. And normal module, module along normal plane. As there are two different plane, okay, and these two plane are making angle alpha with each other. So again there are two circular pitch along normal plane and pitch along transverse plane. And again there are two modules, module along transverse plane and module along normal plane. So it is normal module is denoted by m suffix n, module along normal plane. So what is normal circular pitch? It is the distance between the corresponding point on adjacent teeth measured along the pitch circle in normal plane. In normal plane. Okay. So this is the normal plane. This is normal plane. Okay. And section which is taken along the normal plane. This is normal plane. Section along normal plane. And okay. So what is the definition? The corresponding point on adjacent teeth. Okay, now this A point, consider this A point on that this teeth and corresponding point on adjacent teeth. Okay, this E point here, the adjacent teeth. So AE. Okay, this distance is called normal plane, but you can see here straight distance. It is not a straight distance, it is measured on pitch circle diameter, and pitch circle diameter is a circular distance, it is the arc of circle. So PN is not a straight distance, it is a circular distance. Here you can see a straight distance. Okay, so what is the formula for PN? PN is equal to pi into module, pi into module, and module along normal plane. So Pn will become here Pn is equal to pi into Mn. This is normal plane. Okay, Pn is equal to pi into Mn, module along normal plane. So that is a normal module. The module corresponding to the normal plane is called as normal module. Okay. Now consider triangle ABE. Triangle ABE. Triangle ABE. How the triangle will form here? ABE. AB is nothing but PT, pitch along transverse plane. Okay. And AE, pitch along normal plane. PN. Okay. PT is nothing but AB, and AE is equal to PN. Okay, and these PT and PN will again make angle alpha. Okay, PNN plane and TT plane is making angle alpha here. So parallelity to these two lines is again angle making alpha. So this angle will be alpha. This is 90 degree again. Okay, so consider this triangle cos alpha. See here, cos alpha is equal to AE upon AB. Cos of alpha is equal to AE upon AB. Adjacent side divided by hypotenuse. This will become hypotenuse. So is equal to PN upon PT. Cos alpha is equal to PN upon PT. Cos alpha is equal to Pn upon Pt. So Pn will become is equal to Pt cos alpha. Pn is equal to PT cos alpha. At the same time, what is the formula for Pn and what is the formula for Pt? By putting the value of Pn and Pt, the formula will become here Mn is equal to Mt cos alpha. See here, what is Pn normal module is equal to Mn into pi. Pn is equal to pi into Mn into pi. And what is Pt? Pi into M, pi into module. Okay, but that module is transverse module, pi into Mt into cos alpha. So here pi will get cancelled. It will become Mn is equal to Mt cos alpha. Remember these formulas for solving the numericals. Now, third one is axial pitch, denoted by P suffix A. Pitch axial. Okay, so axial pitch is PA. It is the distance between the corresponding point on adjacent tip measured on the surface in the axial direction. Measured on the surface in the axial direction. So here you can see axial pitch PA measured on the surface along axis of rotation. That's why axial pitch. Okay, this axial pitch PA, this is straight line D up to this transfer A, DA. Okay, this DA and this DE or DC is making angle again alpha. So this form here one triangle A, B, see here A, B, T. This triangle is again okay, and in this ADB angle ADB is alpha become here. Now see here tan alpha in triangle ABD, tan alpha is equal to AB upon AD. Tan alpha, this is tan of alpha is equal to AB upon AD. This will become hypotenuse. So opposite sides divided by adjacent side. So AB divided by AD. And what is AD? That is PA. So PT upon PA. Tan alpha is equal to PT upon PA. See here. Tan alpha is equal to PT upon PA. So PA will become axial pitch is equal to transverse pitch divided by tan alpha. Remember this. Axial pitch is equal to transverse pitch divided by tan alpha. Now come to next definition. Transverse pressure angle. Already in spur gear we already denoted the notation for pressure angle is phi. Okay, so pressure angle along transverse plane phi t. Okay, the definition will become here the pressure angle measured in transverse plane, and that transverse is in the plane of rotation or plane perpendicular to the axis of rotation is called as transverse pressure angle. Pressure angle phi along transverse plane phi t. The pressure angle measured in transverse plane is called transverse pressure angle, and normal pressure angle phi suffix n. Pressure angle along normal plane. The pressure angle measured in normal plane, and that normal plane is plane perpendicular to the tip is called as transverse pressure angle phi n. Okay, the relation of transverse pressure angle and normal pressure angle is denoted by tan phi n is equal to cos into tan phi t. How that relation is derived, that we'll discuss in next session with different figure. Okay, I will share the link for previous session for understanding purpose. Now, next definition is center distance. Center distance. It is the distance between the axis of two meshing helical gear. It is the distance between the axis of two meshing helical gear. Okay, so that C is nothing but CD, center distance. Center to center distance. We can say center to center distance of two meshing helical gear. This is the center of pinion, helical pinion, and this is the center of helical gear or helical wheel. Okay, so center to center distance. Mathematically, it is given by small d, pitch circle diameter of pinion plus pitch circle diameter of gear divided by 2, this center to center distance, or a radius of pitch circle diameter plus a radius of pitch circle diameter for gear, pitch circle radius for pinion plus pitch circle radius for gear. Okay, so what is a d? Which d you have taken on transverse module, on transverse plane or normal plane? So that center distance you can see on transverse plane, plane of rotation. Okay, this view is along transverse plane, so you have to consider the transverse pitch and transverse module. So what is d? D is module is equal to d by t, so d will become here module into t. So module along transverse plane plus teeth on pinion plus transverse module into teeth on gear. I am writing that d in terms of teeth. So that d by module formula will become here m into t, module into teeth. So mt into teeth on pinion plus mt into teeth of gear divided by 2. So center distance will become here transverse module for both the wheels is common. So mt divided by 2 will, I am taking common here, into in bracket tp plus tg. So formula for finding the center distance of helical gear is equal to mt by 2 into bracket summation of teeth on both the wheel, or center distance in terms of normal model. What is the relation of MP and MN? Here you can see MP and MN. Okay, so MN is equal to MT cos alpha. So what is MT? MN divided by cos alpha. MN divided by cos alpha. So MT is equal to MN divided by cos alpha into 2 mn divided by cos alpha into 2 into bracket tp plus tg. So in terms of normal module, the center distance you can write down is mn divided by 2 cos alpha into tp by tg. Okay, so these are some definitions that you have to remember and you have to clearly understand while solving the numericals on helical gears. Okay, so I expect all of you understand these all the terms which are used with relation with helical gears. Okay, so at the end of this session you can clearly understood the terminology of helical gear, and due to this the student can able to solve the numericals on the basis of formulas. Thank you so much.